So far, we've been discussing transformations, shifts, reflections, and scalings, and we've been doing them one at a time, one by one. And so what happens when we combine multiple transformations? Well, we saw that the order does matter. So when combining multiple transformations, the order may matter. And so we need to be careful how we do these. And this is true when we apply arithmetic operations as well. So for example, if I were looking at something like this, the graph of A times f of b x plus h plus k. Okay, well there's a whole lot of transformations going on here. And so let's think about a system for applying these so that we can avoid any trouble. And so here is a method which we'll call the inside out method, which is going to work no matter what transformations are given to us, is that we're going to start on the inside, and the first transformation that we apply is going to be the horizontal shift by h. So I'm just going to put a 1 over that one. Okay, then we stay on the inside, and next we can perform the horizontal scaling or reflection, taking into account the value of b. Okay, so this might be a scaling and a reflection if b is negative. Then we move to the outside, and we perform a vertical scaling on the outside. So the third transformation that we do is we think about what effect A has, and that might be a scaling and or a reflection if A is negative. And then the very last transformation is going to be this vertical shift by a factor, by a value of k. And so we'll call this method, again, the inside out method. So we start on the inside and doing the shift, then the scaling reflection, and then we move to the outside doing the scaling or the reflection, and then finally the vertical shift. Okay, so let's take a look at an example where we are combining several different transformations. Okay, so now in this example, we have a function y equals f of x, and we're told that the point minus 2, 6 is on this graph. And we want to think about, well, what happens when I apply a series of transformations and end up with a function like this? Okay, what transformations have we made, and what's a good order that we can apply those transformations? So in part A, we first just want to get a description of these transformations. So we start on the inside. One way to do this, if we keep our plan of attack from the previous slide in mind, we can start on the inside, and we first apply the horizontal shift. So for part A, first thing I'm going to do is a horizontal shift In this case, we have a plus 3, so that means we actually move it in the negative direction. So we have a horizontal shift to the left by 3 units. Then we take care of the remaining inside transformation, which is the horizontal scaling. So secondly, we have a horizontal scaling by a factor of 1/2. Okay, and again, these inside transformations, we need to be a little careful. When I multiply the inside by 2, that means this is going to make the x-coordinates get halfway closer to the y-axis. And then finally, the last transformation is this 4 on the outside, and that is going to be a vertical shift in this case, up by 4 units. Okay, and so we should check our work before we move on to part B. And the way that we can check our work is actually start with y equals f of x and apply each of these transformations in the order that we've indicated. So if I first did a shift to the left by 3 units, I would wind up with f of x plus 3, right? That would shift the graph to the left 3 units. Then if I do a scaling by a factor of 1/2, horizontally, that means I multiply x by 2. And that would put me here. So far, so good. And now the last transformation that we've identified would be the vertical shift up by 4 units. Okay, and this checks out with what we want to get. Okay, in part B, we now want to track what happens to the point minus 2, 6 after doing these series of 3 transformations. So we start off at the point minus 2, 6, and we shift it to the left 3 units. So we're going to subtract 3 from the x-coordinate. We leave the y-coordinate alone, and at this point we're now at minus 5, 6. So just applying the shift to the left, we would wind up at minus 5, 6. Next, if we do a scaling, a horizontal scaling by 1/2, now this point minus 5, 6 would wind up at minus 5/2, 6. We scale the x-coordinate by 1/2, and then lastly we would take this point minus 5/2, 6, and we shift it vertically in the y direction up 4 units. So we wind up at minus 5/2, 10.